Hello and welcome to today's video. Today I wanted to do a comparison between the QTR and QTRX sensors, the new sensors that have come out from Pololu. Oddly enough, they labeled one QTR even though their old version, which was the red board, was also called QTR. But now they have a whole slew of different sensors. They have QTR, QTRX, and within that they have medium density and high density. So I bought two high density. I have a QTR, which is this one here, 15, and then a QTRX 15 HD. The difference is supposed to be that because these ones have lenses, which you can see here, they are supposed to give you a little bit better reading because of the fact that they have the lenses. So I wanted to compare that and see what kind of results I came up with. Honestly, I'm not really too satisfied with the way I came up with this setup, but I didn't want to wait any longer to get you guys a video, so I just went ahead with it anyway. But basically you have, like I said, QTR here, it's a 15 HD, and then a QTRX 15 HD. And later on I'll do some videos on comparing the HD versus the MD, which is the medium density, which basically is almost every other. So if this has 15, then the board of the same size would probably have 7 or 8. So the way I did this, I have a line here, and then I set up this cradle, kind of chintzy little cradle here. But one of the things I didn't like about it was that I can't have two of the same level pieces of Lego because of these wires here, so I couldn't create a cradle that was nice and even. But this one actually worked out once I got some different height out of my Legos. And so this is what I'll be using. So you can imagine the sensors are right in between these two Legos here, and then I'll be sliding them across, and you'll see on the program that I wrote how this shows up in the comparison between the two sensors. So moving on over to the code. The code for the sensors themselves is pretty simple. I just basically, I have a whole bunch of setup here, QTR, doing the calibration and everything. And what I did is when I did the calibration, I turned off each sensor respectively. So if I'm calibrating the QTRX, I made sure I turned off the QTR so that I don't get interference between the infrared coming from each sensor. Likewise, in my loop, I am turning off the QTR, which is the QTR odd, QTR even, so that's the QTR sensor. And then I'm turning on QTRX odd and QTRX even. So here I'm turning off the QTR on the QTRX. And then in order to calculate the position, because one of the sensors is facing a different direction, I had to invert the position value. So that's what that 14,000 minus is for that. And then the next step is just to turn off the QTRX, turn on the QTR, and take a reading for the QTR sensor itself. Then I send my JSON data. And what this is doing is it's sending it to a program I wrote a few years ago. I never actually finished it, so unfortunately I can't put it out there for people to use, but I'm sure there's something out there by now, because like I said, I wrote it about 3 years ago, but you'll see what that is in a minute. So, I think we're all set with this. So let me plug this in to get it calibrated. Alright, and I'm not sure if you can see it on the camera, but I have a little orange light here indicating the calibration phase. Okay, so it's calibrated. Now I'm going to move over to my Java program that I wrote, and we will start this up. Okay, I connect to my USB modem. All right, here's where the cool stuff comes. We've got a QTR sensor. We've got the positions. And then we've got QTRX. All right, so right off the bat, we can see, I'm actually surprised I'm not getting that good of readings out of my QTR sensor. I might need to recalibrate because it looks like something happened with that. But you can see as I move around here, I'm getting, you can see what sensor what the sensors are seeing, sorry. So as I move to the right, the left sensors are seeing dark, and then as I move to the left, the rightmost sensors are seeing dark. Now I'm going to run this through a recalibration just because of the fact that that doesn't look right for the QTR sensors. All right, let's see what we come up with now. Where'd it go? All right, that looks a little better. Let me just see how this is going to look when I move this around. All right, no, I'm getting some really bad readings here. They're fine that way. Problem is sometimes these breadboards can be a little tricky just because they don't get the greatest connection. And then because I'm using calibration, I'm going to have to recalibrate every single time I make a change in order to see that change. All right, probably should have taped this down, but too late for that. Let's see, stop this. No, still not getting any decent readings. Well, that's not very promising. I know that this was giving me some decent readings from this height. I mean, you can tell it's giving me solid readings, but they're not that great. I'll move on. Well, maybe it'll fix itself over the course of the video. I don't want to stop and do this too much, but like I've always said before, I like to record my videos in real time. I don't like to go back and edit a bunch of stuff. But you can see the QTRX are giving us a really good reading. It is spanning a couple sensors, which is to be expected since we have the HD, and there's 15 in such a small compact area, so I would expect that would be the case. Now, I am a little surprised that these sensors out here aren't seeing more of a white, since they did run through a calibration. I would think that these would be closer to 0, like this one is here. You can see that these are down in the 50s or low or less range, whereas these are above 150. And same thing here. So there's a larger disparity there, it seems, than there is up here. But this is going to be, let me go. Let's see. Sensors here are about 18 millimeters from the board itself, and it says online that for both of these sensors, the optimal range is well, actually for one of them it was 5 millimeters. That's for the QTR, and it was 10 millimeters for QTRX. But it says that they are functional up to 50 millimeters. So I was going to slowly add in some more Legos here to raise these up. So again, that was about 18 millimeters. And we'll see what happens when we move this up. And we're going to have to recalibrate since we just changed the readings. So stop that. run our calibration phase again. All right, let's run this up again, see what happens. All right, we got our QTR, our positions. Yeah, we're still having issues with that QTR sensor. But you can see it's not so much the QTR readings are incorrect, because you can still see that it's seeing a higher reading over in this area, which is comparable to the QTRX. The QTRX, however, is giving us very good readings. We just raised it up another Lego height, which I'm not sure exactly how tall these are. Let's see. All right, so it looks like Legos are about 9.5 millimeters, so they added another 9.5 millimeters, and we're still getting about the same readings. And this, I wouldn't expect the QTR sensors at this point to give us very good readings. Even though the website does say that they work up to 50 millimeters, I don't know if that's a typo, that they just copy pasted that from the QTRX. But from a preliminary testing, I found that the QTR sensors didn't really work well at all past 10 millimeters, which I thought they worked pretty well at 20 millimeters, but we were just at 18 and it didn't work. I was getting the same readings pretty much that I'm getting now, where nothing really went above 150. And here, I'm not even getting anything above, just barely over 100 here. I'm seeing 120 on these two. But you can see there's a pretty significant readback from the QTRX sensors. And if I just look at this here, this is about 27 millimeters, which sounds about right. So that's a little bit over an inch. And now let's try going to add another set of sensors, or another set of Legos. I'll try to take this all the way up to 50 millimeters, which is what they recommend. Or I mean, what they suggest it will work up to. Because sometimes you want the sensor to be far away and you still need to be able to sense the line. So I'm interested to see if we're able to get a sensor that is able to do that. All right, so unplug. I want to get this in the cradle before I start my calibration. All right, so I plugged it in. Start my calibration. All right, calibration is done. Let's start our desktop controller. And here I would probably expect that the QTR sensors are just going to give garbage readings, if not just all zeros. It looks like they're all giving 100 though. But pretty much all the sensors are going to read the same because they're not able to see that far to discern the difference between the white and black on the tape. Now we're starting to see some loss in sensitivity from the QTRX sensor. So you can see there's a lot of spillover, I guess, if you want to call it. These readings over here are still over 500, even though they're that far away the sensor, or that far away from the tape, which is to be expected. The farther you move your line sensor away, the more sensors are going to see a dark reading. So if we move this, we're still able to get a pretty significant readback from the QTRX. Now, again, the QTR, we're not really, I mean, we're seeing some that are over 100, but they're pretty much all in that same range. So whereas before we were seeing some that were lower, lower than 50, here they're all pretty much over 70, between 70 and 130. So the QTR sensor is pretty much useless at this point. QTRX looks like it's, I don't know, I'd have to do some actual testing on a robot to see if this would be a valid reading. because if I move over off the tape, that, I don't know, some of them, they're pretty much all reading over 500 except for that one on the left, which that might just be because it's right next to a Lego. So these ones on the outsides are giving a little bit lower reading than normal because some of the reflectance is coming back from the Legos. Well, it appears both of my batteries for my caliper have died. So I'll just have to read the manual here on the side, and it looks like we're at about 40 millimeters, which is about right because we have about little over four Legos. So if I go one more, that should bring us up close to 50 millimeters. So I'll try that out. One more, and we'll see what happens. Alright, so we can see with the calibration I had, it's pretty useless. Yeah. But let's see if a new calibration is going to give us anything better. So we'll stop that. Start a new calibration phase. Alright, calibration is done. Let's start up our desktop controller. Oh, that took a little while. Let's see, QTR line sensor. Now we're getting all sorts of garbage from the QTR line sensor, which is to be expected. It's pretty much useless at this point, and it was the same at the previous point. Alright, so this is with the new calibration, our QTRX. I don't know, I would say that that's probably not good enough to do a line follow, but again, I'd probably like to put this on a robot at this height and see if that is the case. But if you look at the position down here at the bottom, I believe this one on the right is our QTRX. Yeah, and you can see it's going up to almost 8,000 and down to looks like 6,000 at the lowest. So it's supposed to go from 0 to 15,000. The fact that we're dropped down to 1,500 as our range instead of having 15,000, or sorry, 0 to 14,000. Instead of having a range of 15,000, we only have a range of 1,500. So I'm sure that's not going to be enough to do a PID algorithm. But it's still pretty impressive that we're able to get these sorts of readings back from the QTRX sensor this high up. And, you know, one would think that all of the exposing light coming in from outside, the ambient light coming in, you would think that that would be a factor in the sensor, but it's actually not. I'm not going to go through it here, but I did do some testing before the video and found that the ambient light really had no effect whatsoever. That might be a different case if we had some sunlight with actual high UV rating or a high infrared rating coming in, but I didn't test that. But in the absence of sunlight, the ambient light doesn't seem to be making a difference. Now, one last thing I want to check is maybe bumping this down to just being about 10 millimeters away, which is supposed to be the optimal range for the QTR, and slightly above the optimal range for the QTRX sensor. So let's see how that works. We'll stop this. Recalibrate. Hopefully this shows us some better readings from our QTR sensor, and I know it's not something with the circuit. Alright, so it's calibrated. That looks a little promising. That bouncing around from black to white is probably the library issue that I used to talk about before. the fact that there is some ability for the sensor to roll over, and apparently they have not fixed that in the library yet. Because what I was seeing was, I mean, that's actually how I originally found it, was I was using this tool, and I noticed that my sensors were going from 0 to black. And that made me realize that there was something wrong. So again, it looks like QTR sensor is giving me some bad readings at this distance, but the QTRX is pretty significant in that it looks like what's that, maybe 5 sensors are seeing the black line. And if I took this cradle off and went even closer, yeah, I don't know, it seems for some reason the QTR sensor does not like the cradle, because it seems to be working from outside of the cradle. But I wanted to keep the cradle so that I didn't accidentally keep wobbling it, you know. But yeah, I don't know, the QTR sensor seems a little finicky. I don't know if it's my circuit or if it's the QTR sensor itself. I will try one more time to recalibrate this, but I don't want to keep taking up time on the video. So I'll try one more time. All right. Yeah, it's still not looking good. Yeah, I don't know. I think it's just an issue with the QTR sensor itself. Because if I take it out of the cradle, it seems to be pretty good. And at this range, I seem to be getting a lot more definitive results. I mean, this is literally 0, as opposed to up here where I'm getting like 400, 200. You know, the QTR sensor seems to be a lot more definitive at this range. So, unfortunately, I don't know. I had a lot of issues with the QTR sensor. Maybe it's this cradle. Maybe it doesn't like this cradle for some reason. I don't know. It seems like it's working fine now. So it might just be some bad wiring with the breadboard. But we were able to see that the QTR sensor appears to be a lot better within a 10 millimeter range. So if you can be that close to the line sensor, then you might want to go the QTR route. If you can't be that close to the sensor and you're going to have to be farther away, then the QTRX sensor might be the way to go. Because after you get outside of the 10 millimeter range and you get into the 20 millimeter range and 30 millimeter, the QTRX still is probably not going to be the best solution, but it's probably the only solution at this point until we get something better as far as line following from that distance. So again, I wasn't real excited about the way I had this set up, partly because of the issues I've been having with the breadboard and the circuit. But again, I wanted to get a video out. I know you guys have asked about the QTR versus QTRX. So again, just to sum that up, QTR if you're going to be close to the line, QTRX if you're going to be farther away from the line. And I'll have some future videos on the HD versus the medium density, and hopefully I'll be able to redo this video and get you something a little bit better once I get a better circuit built. So let me know if you have any questions, if you think I missed anything, or if you want to know any more detail on something you think I didn't cover. Let me know down in the comments, and if you liked the video, don't forget to like it and subscribe, and I will see you in the next one. Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.